This will now be recorded.
Good morning, everyone. Screen and audio both are fine or not? Please confirm. Okay. Thank you. Thank you for responding. So I hope everyone is here for the uh, offline. It is not there, Murli. So I hope you all are here for the physical design demo session. So before I start, let me just ask some one or two questions. Like, how many are there who are anyone is there who is from the electrical background, computer science background, or mechanical engineering background? Anyone is there? Electrical, computer science, or any other branch except electronics and communication? Okay. And anyone is there who is MTech, PhD, pursued or pursuing? Okay. EC is fine. Anyone from MTech? Okay, MTech completed. BTech. Okay. Triple E. Triple E is fine. Pursuing. Okay. Okay. Completed. Abhijit. Okay. So one more thing, like, when was your pass out year? So if you have completed your BTech, so mention like BTech pass out year or MTech pass out year. Whether it is pursuing. Okay. If it is pursuing, you can mention pursuing. If you have already passed out, you can mention the year also, your pass out year. Okay. Pursuing, BTech pursuing. Okay. Okay. So yeah, so I hope everyone is recent pass out, most of you, and most of you are pursuing. Pursuing in the sense you are in the final semester, right? Okay. So let us see. So the intention here of this demo session is to understand and have a brief introduction on the physical design. So when I say physical design, what comes in your mind? How it is related, right? So it is nothing but a branch of, or it is one of the stage which is present in VLSI flow, right? Aritra, please have a mute. So it is a branch and it is a one of the stage which is present in the VLSI flow, right? When I say VLSI, right, what comes in your mind, right? When I say VLSI, so anyone who can tell me what is VLSI?
Very large scale integration.
Okay, so when we say very large scale integration, what does this mean? Chip designing. Okay, Gayatri. Very large scale in. So what does this mean? So you might know the full form of it. Very large scale integration. What does this very large scale integration mean actually? Okay, placing large number of transistors are built in single chip, placing large amounts morely, integrating billions of transistors on. Yes, that is correct. So the very large scale integration means when we say that it is a integration, it is an integration, right? So integration of transistors. So integration of transistor when we say, so what we are doing here, we are fabricating, there is, let's say there is some area, right? Now we want to fabricate or we want to design something here. Let's say there are too many designs we have, a design A, some design B, or design C, right? Now what is the difference between these designs, right? So major difference is the transistor count, right? So let's say there is one design which is having something like connectivity based chips, okay, like Bluetooth chip is there, right? So it will have some kind of complexity. Now there are chips which are going to be used in, let's say, washing machine, right? Now it will have its own complexity which cannot be compared with design. Definitely, the design complexity will be different from design to design, right? It is only based on what? Number of transistors, right? Now what we say that there is a law called as Moore's law. What is Moore's law? What is Moore's law? Anyone?
The number of transistors kept doubling uh, over the years.
Okay, doubles every year. Is it exactly double the number? Yes, number of transistors will be doubling. Means what? What is the actual meaning of it? Right, that is correct. Whatever you are saying, transistor count will be doubling every. But how it is possible? how it is possible that for every 2 years your transistor count is getting double, right? Two times. How it is possible? Can anyone answer this? Anyone who can tell me that how it is possible that for every 2 years transistor count is getting doubled? Why it is getting doubled? No, for every 10 years that is not correct, Surya. For every 2 years is correct. So how it is possible that for every 2 years transistor count is getting double? It is only because of its size, right? Size of the transistor. So what if size of the, yes, correct, Gayatri. So what if the size of the transistor is shrinking or getting small, right? So what is the size, right? Now what, when we say size, it is also called as feature size. What does this size means? What is the size of transistor? When we say size of transistor, what does this mean? What does size of transistor means? So when we say a transistor, right? So it is nothing but MOSFET, right? So we have NMOS and PMOS, N plus P, N, right? Then we have oxide layer, gate, and this is nothing but channel, right? Gate, source, drain. It's based upon how we are connecting it. So what do you understand from this, right? What does this mean? Size of transistor means, size means how it is getting smaller, right? So it is only nothing but we will define size with respect to its channel length, right? This length is nothing but called as channel length, right? So that is what we will call it as technology node also. You might have heard many times that design is getting created, right, or drawn on 10 nanometer, 28 nanometer, 45 nanometer, right? So you might have heard the scaling 180 nanometer, 90 nanometer, right? 45 nanometer, 28 nanometer, or 14 nanometer. Can anyone tell me the current size of transistor? Current size on which design is getting created in industry?
3 nanometer.
3 nanometer, okay. Surya 5 nanometer. So latest, yes, 1.8.
Actually, it is 2 nanometer now. Samsung has made it on 2 nanometer.
There is 1.5 also. 1.8, yes, 18 angstrom, right? So two, so lot of companies, design companies are also designing in 2 nan. They have started designing in 2 nanometer. So in maybe in this year you will be seeing some phones, some gadgets which will have the 2 nanometer chips, right? Since I mean the till last year we were seeing gadgets and commercial products which were in 3 nanometer. Okay, so this is the uh, this is the current technology node on which your commercial designs are getting designed. Okay, so understood everyone what is technology node? It is nothing but this channel length of the MOSFET. If channel length of MOSFET changes, the feature size, I mean the device size, will also get changed. MOSFET is a 2D or 3D? Yes, it is a 3D, right? So it will have both length as well as width also, right? Understood? So if this changes, all the feature sizes, right, everything will get changed. Its conductivity will also change, how it conducts, how it produces, how current is getting traveled through this device, that will also change. What will be the driving current, that will also change if your technology node is changing. So when we say the nanometer scale, that is why we will call this as nanotechnology also. It is a nanotech, right? When we say a nanotechnology, how small you can imagine? What is the size? Like when we say how small of means what is the size we can imagine for this transistor? So if anyone can tell me, like what is the size of, you might have seen, right, you might have heard or seen in TVs, right? So you might have gone through those period also, those were COVID period, right? So can anyone tell me what is the size of coronavirus? Anyone? What is the size of coronavirus? Okay, 20 nm, is it? Anyone? You can search and tell me what is the size of coronavirus. Can we see coronavirus from our naked eye?
80 nanometer.
Yeah, so there are different variants. So with respect to variants, it is between 80 nanometer to, let's say, 200 nanometer. So there are different variants with different sizes. Now you can imagine on which scale your industry currently working on. It is working on 2 nm, 1.8, 1.5, right? Now you compare how many times, right? Yes, Sridhar, that is correct. By how many times it is multiples, right? Can you just imagine? Almost like 40 times. It is multiples of what? 40 to 100 times. 40x, 100x smaller compared to coronavirus. So you can just imagine how small your transistor is, that you cannot even see it from your naked eye, right? So then how we are going to design it if we cannot see something from our naked eye, right? How we are going to design it using those transistors? When we say a VLSI, right? We also have LSI, large scale integration, right? We also have medium scale integration, which is also called as MSI. We have small scale integration, right? Above VLSI, we nowadays we are also having ultra very large scale, right? Is ultra small. So when we say very integration in the large scale or very large scale, what does this mean? Means it follows Moore's law. It is following Moore's law. By Moore's law, it says that for every 2 years, transistor count is doubling. So how it is doubling? It is only because of feature size. Feature size which is getting shrinked. Now, if feature size is getting shrinked or very small in nanotech or nanoscale, right? How we are, so now challenge is with this small, which you cannot see, how you can design it, how to design this. It's a very difficult part now, right? The thing which you cannot see, how it can be designed. See, you might have drawn many circuits in your colleges, or if you have worked somewhere, you might have designed and right. So, for this purpose, we will be requiring some kind of CAD edit tools, right? Computer edit tools will be required. Those tools are called as EDA tools, right? What are EDA tools? So it is nothing but electronic design automation. Now we want to design something which is in nanoscale. Definitely will require some kind of support. Now that support is coming from the computer aided support. Now that is called as electronic design automation. Okay. Now when we say electronic design automation, right? Can anyone tell me any tool names which you know, if you know? What are electronic design automation? Yes, correct, Gayatri. So Cadence and Synopsys are the two EDA based companies, right? They are like CAD based companies which develops CAD tools for VLSI designing, right? So there are many tools from Synopsys as well as Cadence. Anyone, if you know? So we have ICC2 from Synopsys. I'll write it here. From Synopsys, we have ICC2. Yes, all prime time. These all are what? Then from Synopsys for STA, we have prime time. From Cadence, Innovus. Yes, Virtuoso, Altium. All these are EDA tools. Innovus. And for front end, we also have Questa Sim. For power analysis, Red Hawk. For physical verification, Caliber, right? So these are some examples of tools which is called as electronic design automation tool, which will help us to analyze the design in nanoscale, right? Now these tools are very expensive. These are not open source tools, right? These are not free. So these tools are having some kind of licenses, and these licenses are very costly, right? It is, you need to purchase it if you want to use this tool, very costly. That also, the single license, I think it's not sold, it is sold in bulk. So in our institute, we'll be providing you, so designing understanding is not only important. Second important thing is that we must have hands-on such industry level tool also, right? For that purpose, in our institute, we will having ICC2, Synopsys ICC2, Cadence in our Innovus tools, right? Prime time. For synthesis, we will have design compiler from Synopsys, right? We'll have ICC2, right? So these tools are available for designing in our institute, which is a licensed tool. Industry level standards we have. So this is what, how we are going to design and with what support. Understood, everyone? So we'll discuss more. So let us talk more about course now, right? So let me just go to that slide. So this was just the introduction of what is VLSI and what is the thing we are doing it, right? So thing is, after designing, one more before going to course, let me just tell you. So this is VLSI, and after, let's say we have used this tool and we have designed it. So then what? So once your design is completed, then what is the next step? Tape out, absolutely correct, right? Tape out means what? tape out means, so now the last destination is tape out, or which is also called as, so it will go to foundry. So whatever you have designed, yes, manufacturing, correct, Gayatri. So whatever you have designed, right, in nanoscale, now after verification, that needs to be sent to foundry. Foundry, or it is also called as fab lab, fabrication lab, right? Now what happens in fabrication lab? Can anyone tell me? So what happens in fabrication lab? What happens in fabrication lab? When we say a fabrication, right? You might heard this word many times, right? Like, this word originated from fabric. What is fabric? So any cloth piece, right? Any dress, any cloth piece is called as fabric, we say. Now if you take multiple number of threads, different color threads with different color type, I mean some silk, cotton, or linen, right? A different color and type, some jerry type of threads, right? You take multiple threads, multiple color, and now you stitch it in hand loom, right? We are not stitching actually, so we are what, we are assembling it, right, in hand loom. So that is the process, what we call that, it is called as fabrication. So from here only similar analogy is drawn in the VLSI fabrication also, right? So what happens in VLSI? So here we assemble or fabricate what? Transistor devices. Transistor devices on, anyone? On silicon. Silicon wafer, right? Silicon wafer. So when we say silicon wafer, you might have heard this word many times, right? What does this wafer means, right? So you take a potato, so you might have eaten potato chips, right? How it is made, how it is cooked. So you take a potato and slice it, you will slice it, right? After slicing this potato, what will, how your cross sectional surface will look like? Many dies in circular slice, thin silicon, yes, correct. So after you slice it, so you'll see a oval shape surface, right? A cross sectional shape. Now this is called as wafer. So when once it is fried, then only it is called as wafer, of course. So same thing. So you take a silicon. So how we are getting a silicon? What is the source of silicon? What is the source of silicon? How we are getting silicon? Yes, sand. So there are two semiconductors actually available. What are those? There are two semiconductors in, you might have seen periodic table, right? There are two semiconductors. What are those? What are those two semiconductors? One is silicon, yes, Venu, correct. Second one is germanium, right? Out of this, which one is better? Can anyone tell me? Silicon or germanium? Silicon or germanium? Yes, yes,
Germanium, I think.
yes. Your name?
Ashish.
Yes, Ashish,
Because
correct.
germanium's band gap is zero point 0.5, I think. Initial
Point
0.5
five or
ohm.
point 3?
0.3, I think. Oh, sorry. and silicon is point 0.5. I think.
Point 0.5 or
Point
point 0.7?
0.7, point 0.7, point 0.7.
Correct. So the what we said, the threshold voltage, right?
Yes, yes. Threshold voltage is point 0.7 and
Correct, Ashish.
germanium is point.
So threshold voltage in silicon is zero point 0.7 volt, and in germanium it is zero point 0.3. Yes, zero point 0.4 is also there. It is a range actually, Gayatri. Absolutely, to be very precise, it is zero point 0.3 to zero point 0.4 volt. Right. So germanium is better in terms of conductivity. It will conduct in shorter period of time. It does not need to wait for to reach zero point 0.7. It will start conducting from zero point 0.3 itself, or point between zero point 0.3 to zero point 0.4. But then why we choose silicon as our major source in semiconductor? What is the reason? If germanium is better, then why we are choosing silicon? Because
Availability.
yes, correct. Because cost as well as availability. It is having low cost and abundant in nature, right? So what is that? It is sand. So we take lot of sand, and these sand particles are melted, and silicon is extracted from the sand, and then it is converted or molded into ingot. This is called as silicon ingot. So a cylindrical like piece. Oh, not photolithography. That is a later stage. First, you need to get wafer, right? First, you need to get silicon. So this is called as silicon ingot, right? Now this is sliced. This is a cylindrical shape. Do not. It is a 3D. Okay. It is a cylindrical shape. After making it into slices, right, you will see cross sectional area as a circular disc, or you can say wafer. It will look like disc, or you can say wafer. Now this is called as silicon disc or silicon wafer. Now this wafer is taken into that fab lab, and there are fabrication step. It goes through fabrication step. Like what? Etching and photolithography, right? We say that etching and photolithography, right? So what does photolithography means? So litho here means it is related with something like stones, right? Or photo means, right, how we are getting the design, how design is printed. It is by photons, right? And graphy is nothing but a correlation of design actually. So itching, you might have heard this word itching, right? Have you heard this word itching? What is itching?
Etching means removal of excess copper.
Yes, etching, yes, correct. That is removing of excess metal. So when we say etching of the excess metal, so you might have done some lab work or experiment in your college. You have taken one PCB, right? You have taken one copper clad. So how many of you have done this? Circuit designing, you have taken copper clad. Then what we will do? We'll print the design, right? Something like this. What is this called as? We'll take black marker or something, we'll print in Eagle software, and then we'll imprint on this copper clad, right? This black color line. You know it? Anyone? I'll
Yes.
just You have seen this kind of PCBs. Many times you have seen this circuit, right? This is called as PCB. So before getting a design, right? How we are getting this design? If you see, it is having some kind of network, and these dots will have holes, which will be helpful in connecting components, right? And this orange color part is nothing but the metal part, and this is nothing but a polymer, a plastic, uh, a clad, right? So what we are doing here, how we are getting the design? So we are getting the design. First we need to draw that design on complete copper clad. So it will have complete all copper, right? So just like this, if you see here, so it will be, it will look like this, something like this. So it has all the copper on top of it, right? But we need a particular connection only, right? How we are getting? First you need to draw the circuit on top of it, right? What is this? What is this? How, why we are drawing this? So it is acting like a photoresist, right? It is acting like a photoresist. So you take some marker or something like printing black color, some ink, right? So it will act like a photoresist. Photoresist means when photons imparted on top of this clad, right? It will not wash off copper, or it will not etch the copper in these marked location. It will protect it. So wherever this photoresist is not drawn, right? So when their photons will fall, impart on this copper clad, it will react with what? The copper which is exposed to the photons, and these copper will be washed off, right? So this is a chemical process, a chemical process where we require a ferrichloride solution, plus we require a UV light, right? So UV light is nothing but the source of photons. So in this presence, your copper will be etched off where photoresist is not present. So this is a process of having the connection. The same process is applied in fabrication steps also, but only difference is the nanoscale, right? It is fabricated in nanoscale. So that is why fabrication becomes more complex compared to PCB designing, right? Now what happens here? So similar kind of, so very complex things are there in fabrication lab. A UV light, right? So now we have a silicon wafer. How to print the design on silicon wafer? So it will have etching process, of course. But let's say you want a certain type of design. Let's say like this. Some kind of connection you want. How to print that? Like how you will get this design? Here we cannot use marker pen and draw this connectivity. Here we cannot draw with manual thing, right? It is very very small. As I say, it is in nano scale. Now how to draw that design? So it is by, so we will take what? Mask. So if you have seen during Deepavali, right? So you will see in market there are a lot of stencils, Rangoli stencils. You might have seen, right? Everyone has seen, right? Or in your school days, in geography class, you might have used one map of India stencil. And so there will be like something like this. So map of India stencil, right? What this do? So it is, you take one Rangoli stencil. Let's say there is a Rangoli stencil, something like this. You have taken this. And what you do? You take this stencil and you add colors into these pores, right? Wherever pores are there, color will fall on ground, and that design will be printed, right? Now these stencils, or this is kind of what called as mask. right? Now you take two more stencil or one another stencil and place it on top of this stencil, which has a different design. Let's say a design of star is there, right? Now this flower plus this star. So what will be printed on ground? So there will be star and then there will be flower, right? So combination of mask will help you to get a different design. Mask 2, mask 1 like this. Similar way, we will have a different set of mask for different layers, right? When we say MOSFET, right? We are fabricating what? Transistors, MOSFETs. So when we say MOSFET, how many layers are there in MOSFET? How many layers are there in MOSFETs? Anyone? So you might have learned CMOS in your college, CMOS or electronics. How many layers? Anyone? So there is substrate, right? Substrate. So there is N-type material, right? In NMOS we have N diffusion. In PMOS we have P diffusion. Then we have silicon dioxide, right? Then we have polysilicon. Then we have implant layers. All these layers are present, right, in a MOSFET design. Now when we say a semiconductor fabrication, it happens layer by layer, right? So the bottommost or the base layer of silicon wafer is nothing but a substrate. It is completely what? A substrate, right? So I can show you. So what happens? You can see here. So this is not. So this is what? Substrate. And then we have N diffusion, silicon dioxide, then gate. And what are these gray color region? It is nothing but metal, or we can say pins, which will be connected to metal layers, which will be going to be fabricated on top of devices, which will be used for interconnects. Clear? So layer by layer it will be fabricated, substrate and then diffusion layer, and then multiple number of transistors will be fabricated at one go, right? So then this wafer will come out as a output, and this complete wafer, right, it will be cut into pieces, because in single wafer you will have multiple number of designs. Same design only. Let's say you are designing a processor, right? A Intel processor. So you will have multiple number of Intel. Let's say you are designing i3 Intel processor. All these are i3 only, right? So this will be cut off. This will be cut into smaller chips. What is the size of chip? What is the size of chip? Like approximated, what is the size of chip? So this, once this is cut out into one piece, what do you think? What is the expected or approximated size of this chip? So it is the size of your thumbnail. What is the size of your thumbnail? Approximately the size of the chip is with respect to thumbnail. So whatever you see in your motherboard, right? Have you seen motherboard in CPU? Yes, 200 mm to 300 mm square. So in your motherboard, you will be seeing a bigger size of matchbox, right? Have you seen? a processor size, or in your mobile also, the size will be somewhat bigger, a black color box. Have you seen? But that is not the size of chip, right? The chip is inside that box, which is the size of your thumbnail, right? And then why we are leaving this space? The space is we are leaving it for interconnects, for connecting the pins. Understood? So this is how it is from sand to product. This is the journey of sand to a semiconductor chip, and then these chips will be sold and it will be fabricated in different commercial products, right? Can you tell me what are the applications which you see in industry? What are the applications where silicon chips can be used or semiconductor chips can be used, where you see VLSI based chips or silicon based chips in? Can you tell me any example? Application means products, right? What products you see? In which products? Yes, mobile phones.
Laptops,
Correct.
personal computers, cars, aeroplanes.
Yes.
Basically, everything nowadays has a
Automobiles.
semiconductor.
Yes, correct. Aircraft. Right. Anything else? Laptops, computers. Anything
Yes.
else? Yes, military applications. How many you can tell me? All, whatever you know. Military applications and
Consumable electronics.
yes, correct. Consumer electronics. Like like what?
Fridge, AC.
Correct. Fridge, daily based, what we use in
Yes.
daily basis. Fridge, washing machine,
Machine, AC, air
AC,
conditioners.
right? Televisions. Now we are having smart television. We are having smart homes, right? Smart homes. You just give a order like switch off this room's light. It will switch off. Switch on the sun. Switch on the fan. Switch on the AC. Smart homes. Check for the security. Yes, medical application is also very important. Lot of medical applications. Now there is one research paper you can also search. Now they are developing nanobots, right? So this is a nano biobots actually. So these nanobots can be injected through syringe in your bloodstream. So this is a field of research actually, which is ongoing. So this can be injected in bloodstream to detect cancer and to neutralize those cancer cells. Right. So this is just one example, very interesting example here. So the nanobots will be very, very small actually, which is bio-friendly, right? Which can be bio-friendly and it will be helpful in neutralizing your cancer cells or destroying your cancer cells, right? Apart from that, there are a lot of equipments which operates in heavy power supply. Like what? CT scan. You do CT scan, MRI, right? X-ray machines. Nowadays, X-ray machines are also having what? Semiconductors, semiconductor-based chips. In automobiles, nowadays we are having what? ADAS system. What is ADAS system? Anyone? What is ADAS? is IoT based devices. What is ADAS system? No one knows. ADAS system. That is what advanced driver assistance means. It is kind of autopilot mode. Autopilot, right? You don't have to drive. So it is a completely automatic. You don't have to drive using steering wheel in the cars, right? Nowadays, you might have heard about Tesla, Tata, Mahindra. These all are developing such kind of cars, which is what EV vehicles, plus also having ADAS kind of system, autopilot system, right? Even now in battery management system in these cars requires a semiconductor chips, right? So that is also requiring what? A separate semiconductor chip to manage battery in EV vehicles efficiently. Solar, right? We are also developing what? Solar power energy. Now that can also be controlled by semiconductor chips. Solar power energy. And so in military application, missiles, tanks, sixth generation, fifth generation aircrafts, right? Those also require what? Semiconductor chips. Recently in Ahmedabad, a phase one of Micron Fab Lab has been constructed in last year December. So phase two is also under development, right? So phase one is operational. Micron Fab Lab phase one is operational in Ahmedabad. Okay, so there are many application. You name it nowadays, even in helmets. So nowadays, helmets. So in sports also. Now in sports also, lot of semiconductor devices are used, right? Like what? Now if you see Indian cricket team, right? If you see the Indian cricket team, now they're having lot of that kind of machinery which tells what is their performance, how their performance is degrading or improving based upon their health, right? Like what? Their pulses, their oxygen level, their blood stream, right? How their blood is flowing. Nowadays we are also having those kind of chips which can tell that how blood is flowing through your, through which part of brain, through which part of brain, right? So numerous number of applications are going on based on some are going in at research level and some are already developed, right? So it is having a very good future. Okay, so this was just a brief introduction here. So let us talk about course also, right? How we are going to proceed. And then I will give you somewhat briefing on physical design and ASIC flow also. So the course will have total duration of 6 months. So first phase will have PD basics and second phase will have PD advanced sessions. So in the PD basics, it will consist, so we will have 2.5 months for complete basics. So many of you are just in final sem, and many of you have passed out maybe 3 years back, 5 years back, right? So you might have disconnected with the basics, right? You want to revise it, you want to learn it, right? Again, you want to brush it off. So for that, yes, so it is not the exact 6 months. So 6 to 8 months, not exactly 6 months. So usually it gets extended. If everything is, so it also depends on the batch to batch actually. So at least 6 months, why we say? Because let's say there are some batches who are fast learner. That is the first question which I have asked. Like if you are a B Tech or M Tech or a PhD. So if there is a batch who is from MTech VLSI design, so definitely for those batches we do not require 8 months, because they are fast in learning things, because they have already gone through those subjects, right? Those concepts. So for those we require less time. So that is why we keep at least. So there is a thing. Total duration will be approximately 6 to 8 months. Okay. So the first 2.5 months we will have PD basics, in which we will brush your uh, yes, even though you are pursuing, right? So you might have learned digital basics in your second year or third semester, right? You might have learned CMAS basics in your fifth semester or third year. You want to revise it, you want to learn it. So the basics here, we are not going to cover all your basics what you have learned in graduation. The basics which we are going to cover here, which will be truly or related to what is required to understand VLSI design or physical design, that will be covered, because we have a very stringent period of time. In that time we need to cover a lot of things, right? PD is a very vast, VLSI itself is a very vast, and in that PD itself is a very vast topic. Okay, so we will be covering digital basics. So GVim is nothing but a text editor, like a notepad you use, right? And then we have a Unix. We have Unix, Linux command, so which is a operating system, right? So you know that every industry is now working in Unix and Linux based environment. And then we will also see somewhat scripting, tickle basics, right? Then we'll see CMOS basics. Tickle is nothing but a scripting language, and physical design basics also we'll see. So class timing for PD basics will be on weekdays from Monday to Saturday 3 hours, and weekends also on Saturday Sunday 3 hours. Sure, I'm not in that group. You can check with the admin in that group, they will share it. Learning resources. So the classes will only not go live. It will be both online as well as offline. So there will be live recorded videos, which will be, every live session will be recorded, and it will be uploaded in your user ID, right? So and there will also be pre-recorded videos. So in the PD Advance, which will consist of 4 months, so here we will be covering all Synopsys, DC design compiler, ICC2 from Synopsys, right? Prime time, Fusion compiler, Star C, Star RC. Cadence, from Cadence will have Innovus, Genus, Tempus, and PVS, right? Class structure here, in weekdays from Monday to Thursday we will have labs, right? So where you will learn hands-on of physical designing or VLSI designing in tools, right? So in industry, what is the expectation is that you must able to design um, VLSI chips, okay, using these EDA tools. So you must have some level of understanding on these tools. So timing will be from 10 a.m. to 1 p.m. and there will be another slot which is 2 p.m. to 5 p.m. And this timing is flexible based on batch requirement and trainers availability. You will be provided with one slot. Okay. Weekends, on weekends, we will be providing you with the theory session. That will be mostly from 9 a.m. to 12 p.m. or 10 a.m. to 1 p.m. Or sometimes that theory session will go in afternoon session also. So it is the interchanging. So if theory session is in morning, lab session will happen in afternoon, 2 p.m. to 5 p.m. Okay, any question here? Any questions in class timing? Okay. Now, the one thing I want to tell here before we move to next, right? So there are two types of batches here, right? One is a regular batch who are available for weekdays, and second one is the online batches. The people who are working, they do not have time, so they will require some. Um, they cannot attend in weekdays. So for them, we have weekend batches, right? They can attend only on weekends. That is, you will have theory session and lab session on the Saturday and Sunday. Sir, how much duration we will be able to have access to live? Complete your 8 months, 6 to 8 months, how much your batch is going on, right? Till that time, you will have all your recorded videos, your live pre-recorded videos, and tool access also. Tool access will also given throughout your course, 24 by 7. All weeks, 24 hours access will be provided to you. So Monday to Sunday we have classes. Yes. So all days you will have classes. Monday to Sunday for regular. If you are working Santosh, then you can opt for weekend batches. Okay. So once you have completed this course. No holiday. Usually the Fridays are given as holiday, right? So for Monday to Thursday you will have lab sessions. On Friday you will be provided with a holiday. Sunday is not holiday. Archita, the Sunday, why it is not holiday? Because the trainers we are providing here, right? Those are from the industry and they have the industry level experience and experts in the subject. That is why we will not provide holiday on Sunday. So those people are available on Saturdays and Sunday. Will use Fusion compiler or ICC2. So we'll basically use ICC2. Fusion compiler, Abhijit, is not very much different from ICC2. It is similar to ICC2 only. Whatever command you use in ICC2, same type of commands you will see in FC also. Sir, any career gap matter to get placement in VLSI? Career gap does not matter. So when is your pass out, Srinivas? Sir, if coaching is completed until place the tools, will give access coaching. After coaching completion also, we'll give 2 weeks, some 1 week to 2 week extension to have recorded and tool access. Sir, is there any test after 2.5 months of basics, Rahman? Yes, Rahman, it will be there. I'll explain that in next slide. Sir, can we do this course offline, coming there and doing it physically? Yes, Soham, both things are, like I said, both online mode as well as offline mode is there. Whatever you opt for online mode, you opt for offline mode. If you're opting for offline mode, then your attendance will be tracked. So you have to come daily in institute, lab session or the theory session you have to attend physically. 100 placements is either 100% placement in company. So 100% no one can guarantee unless and until. So this is not a one way thing, right? So if someone is teaching something and the course structure is given to you, right? If you're following through that, definitely you will get the opportunity to get something without doing, right, without doing anything, hoping that there will be placement, you will get something. So it's very difficult to commit on that. For offline student in Hyderabad, we have to come to Madhapur every day. The Hyderabad batch, you can check with management Santosh, like how they are following. How many companies collaborate in VLSI companies? So there are many service-based companies as well as product-based companies which are collaborated with us. I'll explain that in the end of session, which company and what. Then what about Hyderabad branch? Hyderabad branch, I will explain. So there we will have a lot of trainers which will be coming in Hyderabad location also. So companies usually don't have physical design engineer for fresher. For fresher also, I'll explain that what are the opportunities as a fresher you have, Satvik. So let me just, okay, we'll take another set of question after some time. Let me just go through the presentation. Right now, many people have asked questions related to. Sir, I have a 5 years. It is fine. 5 years of experience in different. It is fine, Gautam. But which domain that is more important? Whether if it is a VLSI domain or it is in some non-electronics, non-VLSI domain, hardware testing. Hardware testing in nanoscale or what? So I'm third year student. After taking this course, do I need to do MTech? Not required. See, the purpose of this course or purpose of this training is to make you industry ready, right? So once you are industry ready, you are ready to go into industry and work, right? That is the goal of this training. So why we need a MTech then? So MTech is not only to get a job. MTech, some people are interested in research also. They will choose for MTech and then they will go for PhD also. To get a job, MTech is not required. You can have one training with EDA tool support and you can get into VLSI. So learning and research or going into something like in R&D, then MTech is will be helpful in that case. Will they consider my experience? No, if hardware testing, if it is not in nanoscale, that experience won't be considered. So recently, how many students got placed through VLSI Guru? All these answers I'll be explaining in the end of session. So just let us go through some more presentation and then I'll take some more question. Okay. So placement support and interview many people have asked related to placement. So thing is the 100% placement no one can provide, only if that can be achieved only if we have a two-way interaction, or what we are following here, whatever structure we are following here, whatever trainer is teaching both lab as well as theoretically, conceptually, whether you are grasping or not, whether you are properly giving the answers or not, attending all the sessions or not. So you must regularly attend all session, and there will be regular assessment during your PD basics and PD advanced. Suppose a digital session is going through, right? And your digital session is completed. Now there will be test after digital session, like how much you have learned to track your progress. Okay, suppose you are in PD advanced and you are having EDA tool lab hands-on. So we will see that whether you are able to solve any problem or not, the exercise which is given in lab session, whether you are able to solve or not. So these kind of assessment will be happening throughout your course, right? After each subject, let's say CMAS completed, then you will have test. After GVim or Linux completed, then you will have another test. This test is not for us, of course. It will help us to assess your progress, your performance, as well as individual level also. You will come to understand that how much I have learned, how much I am, what is my understanding level, whether I am progressing or not. So this test is helpful to you also to assess your progress, as well as it is helpful for us also to track your performance. So based on how you perform in these all tests and exams, so you will be categorized into one list. So of course, those who are having the best performance will have great opportunities, right? Then to improve your interviews, so many cases I have seen, so they are very good in concept, they are very good in theory, but somehow they are lacking in communication skill. They're not able to properly give interviews. They know the answers, but they are not able to express. They're not able to introduce themselves. They're not able to talk and explain more, right? This all comes under soft skill and communication. How to write, right? So the continuous mark interviews and regular feedback will be suggested to you, like where and which part you can improve, right? Next, parallelly, we will also have soft skill and resume building sessions, which will be helpful in your shortlisting of resume in industry. The first most gating thing in selection is the resume, right? So there also will be helping you. So guidance will be continuously on given to you on frequent basis. What are the prerequisites required for this course? Like, do we need to learn Verilog? No, Soham. Verilog is not required. Okay. So for physical design, Verilog is. So I have already told what are the prerequisites, or what, even I will not call it as prerequisite. The only prerequisite here, right? Let me just write here. What are the prerequisites? So prerequisite is that you should be at least BTech B graduate, right? In triple E, EC, electrical, right? So this is the prerequisite. That's all. Now what should be the percentage? So there is no cap. So there is no percentage cap. Suppose you got 45%, it's okay. You got 50%, it's okay, right? Or let's say nowadays we are having CGPA and GPA. So you have a 5 pointer, 6 pointer, right? It's okay. These numbers are okay. So only prerequisite is that you should be BE BTech. So those who are pursuing, they should be at least in final year, fourth year. Okay. Any question in prerequisite? CS, mechanical, civil. So usually they are not hired. Computer science, mechanical, and civil. Company consider this percentage? No, usually, so depends on company to company. If you have a higher percentage, definitely the preference wise they will go with the higher percentage person. But it does not mean that you won't get anything. Of course, there are pool of company. So there are categories of company: category A company, category B company, category C company, category D company. So all these belongs to VLSI, and definitely you will get something. It's not like that. So let us. Yes, Archita, I'll be training for you. So there are multiple trainers, whether I'll be assigned for your batch or a different trainer, so that we need to see. So I'll be starting from the scratch. So I will not take the PD basics part, so there will be another trainers. So I'll be taking the PD advanced session for you, right? From scratch onwards, whatever the basic level requirement is required to understand physical design, I'll teach everything. Okay, so let us move to next. So the process is very clear here, right? So first step is you need to complete each and every session and complete all your assignments, both lab as well as theoretical. Clear your all internal test, mock interviews, and interview preparation. I'll come to that point also, Sridhar. Appear for interview with hiring partners. This is the last step. Okay. So let us take a 5 minutes break, 5-10 minutes break, and then we'll resume. So we'll again resume at 5, 11, 6. Okay. And then we'll discuss the ASIC flow, and then we'll have the question round. So let us take a 5, 6, 5, 7 minutes break. I'll resume at 11. So 11, 8 a.m. Okay. Okay, let us resume from here. Okay, I have one question. Sir, how are test or evaluation done? Yes, I'll explain that. So test will be regularly taken. Let me explain here. So PD basics, right? So there are digital CMOS. So if you have completed digital, right? So there will be one test. You have to pass this test. Then you will have CMOS. Then you will have second test. You have to pass the CMOS. Suppose you are not passing, you have failed, right? Then in that case, what will happen? Suppose you have failed any of these PD basics test, right? You will not be sent to PD advance. So to have PD advanced session, you need to first pass the PD basic sessions or the test, right? You have to pass these two tests. Suppose you have failed, right? Then we will also provide you support sessions. Support session means like a revision session. Revision session will also provide it. Suppose you haven't understood anything, any concept, and you want to revisit it, you want to revise it again. So revision support sessions will also provided with respect to individuals if you have failed the test, right? This is how test will happen. So there will be scoring. So you have to pass this test. So the scoring will be told by the trainer, right? PD advance. In PD advance also we will have test after each stages. Like we will have test after floor plan, we'll have test after PNR, right? And we'll have test after STA also, right? So this will help you to track how I am learning, how much I have understood. All these scores will be tracked and will be kept into your Excel sheet, right? How much you have scored in basics, how much you have scored in PD advance. So there will be one final score, right? There will be one final score. Now this final score, on based of this final score, your you will be categorized in your list, in your batch list, right? Where you stand. That will happen. Any question? Is it clear how test will happen, how it will be checked? So your test will be both online and offline, right? And you can upload your document after test into the portal or the link which is provided to you, right? So this test is basically, the agenda of this test is not to filter you. This test agenda is to improve, right? It is not to filter you, it is to improve yourself. Suppose you have failed the any one of these tests, you have failed, did not score well, right? In that way you will also come to know that why I failed, where are my mistakes. Test is online or both online and offline, you can attend offline also. So the thing is how you are revise, how you are working, right? How you are learning. So that all things you will understand where I am failing, which topic I am not able to answer, right? So that will help you overall. And plus it will also help the institute also to see your performance level, how you are improving, how you are progressing, whether you require any revision session support or not. If you require, you can immediately come to institute and you can ask the management that I want revision session for a particular digital concept again. I want a revision session for CMOS. I want a revision session for a floor plan. I want a revision session for some XYZ. I want some extra lab session, right? That can also be provided. In terms of support and help, whatever you need in terms of learning, so institute will be always there on your side to help you. That is for very clear from institute side. Okay, whatever additional things you require, institute will help you in that. Okay, so let us come back. So let us quickly go through. So we have already discussed many points from here, that what it involves, what is fabrication, and what are all foundries. So there are basically two types of design companies. I mean, two types of companies. One is design-based companies. One is fabrication-based companies. If you know, there are multiple fabrication foundries in world. Those are TSMC, Global Foundries, Samsung, Intel. All these are what? Fabrication based companies. So major market share which is having, right, which is by TSMC. Okay. Yes. Akansha, you can mute. Chaitanya. Yeah, you can please mute. Yeah, thank you. Okay, so the key tools. So those are what? EDA tools. Right. So fabrication also we require certain types of tool, but we are more focused on designing part, right? So we'll be using ICC2, Innovus, so Fusion Compiler, all these tool access we have. Process. So the process I have already explained, that etching, doping, photolithography process is part of fabrication. Chip designing, I'll explain you what is the design flow, right? What is the final output? Just in initial only I have explained that it is nothing but a silicon wafer or an integrated chip which will be mounted in one package, and that can be mounted on one PCB board, right? That is the final output of fabrication. What is the final output of design? So what is the thing that is called as tape out, right? Tape out of what? Your complete design layout, and it is in the format of GDHS2, sorry, GDS2. Okay. Dependencies for fabrication is nothing but on the design file, that is GDS. So what fabrication person is expecting from a design team, they're expecting the GDS2 file. Okay. And what designer relies on? Designer relies on the foundry manufacturing chip layout rules, right? Suppose the foundry is on 28 nanometer. Okay, so 28 nanometer will have certain types of constraints or some certain types of rules and restrictions will be there. It is a complete machinery, right? So if it is fabricating 28 nanometer, immediately it cannot shift and fabricate 14 nanometer and 10 nanometer, right? The machinery is very costly, the setup is very costly, so it will have certain amount of restriction and rules that a designer needs to be follow. They need to follow those rules. Okay. Now what is GDS2? This is the final output of a design team, right? It is nothing but a graphic data system, right? So which will be helping us to store your design into a binary format or a small, because our design is very complex, very big, so the file size will be very huge. For that reason only we will have a binary file to store our design, right? So it is not a non-encrypted file, it is an encrypted file. It is a non-readable file, you cannot read it, right? So what is defined in GDS2 actually? So you will not find any transistor defined in GDS2. So all layers, right? So you have polysilicon, you have diffusion layers, you have metal layers, you have contacts, vias. All these layers are defined in GDS2. Okay. So it is defined based on layers, which layer is located where and how it is connected. Now we will talk about the complete VLSI design flow also, right? So there is Semi-custom and full custom both design. So usually in industry we follow what? ASIC design flow. What is ASIC design flow? What is ASIC? ASIC. ASIC stands for application specific integrated circuit. Now when we say application specific means designing of a chip, designing of an integrated circuit which is specific to certain applications, specific to perform specific application. Suppose you want to design a chip which is specific to washing machine, right? That washing machine chip should not operate like a air conditioned chip, right? That washing machine chip should not operate like a mobile chip. So the chips which are very much specific to perform specific type of application, right, that becomes application. So usually ASIC design flow is used for consumer electronics, like so if you see in market also the major products which are coming in market are from the consumer electronic market, right? Military based applications or the medical based applications are very much stringent and very much precise, right? Very much small group, right? It's not a very much big consumer base. Consumer base is very huge in consumer electronics. Okay. So the evolution of IC I have just explained in initial session only, right? So whenever the design is getting designed, right, whether it is small scale integration which has a few transistor, or whether it is a very large scale integration which has a many number of transistor, more the number of transistor means the complex design it can hold in smaller area, right? So chip number of chip count will also increase. So if you have more number of transistor, more complex design means you can get more performance based design. So you might have, let's say for example, phones, right? When you go to purchase a phone, what you look into phone? What are the features you look into phone? Anyone? So just casually you can tell.
Processor, camera,
Correct. Right. You see that which processor this one, whether it is dual core, quad core, or octa core, right? Then you see RAM, right? So whether it is 2 GB RAM, 4 GB RAM, 8 GB RAM, yes, storage is also important. Then you will see that whether it is having 128 GB inbuilt or 256 GB, and what else? So there is a term called as refresh rate, right? Nowadays, people will say, what is the refresh rate of your screen? What is refresh rate? 90 hertz. You might have seen, right? You might have read 90 hertz or more than 90 hertz refresh rate. Now, even you will go for screen also, whether it is a AMOLED display, whether it is a LCD display, right or wrong, or whether it is a OLED display. So there are now different types of display in your mobile phones also. Anything else? Battery is also important. Now you will see that your phone should last for 2 days, complete one day without charging, right? It should have more 6000 mAh battery, 5500 mAh battery, right? That is also important. Now you will also look for whether this phone has a battery management system or not, or power optimization is better or not, right? Power saving features are there or not. Yes. Anything else? Many things are there. You go for phone and you will see different things, right? So there are different purposes. So some people have choices like I want a camera phone which has a better camera. Some people have choices like I want phone which is more friendlier to gaming, right? So usually people play games, right? In mobile phones, what happens for mobile phone easily gets what heated, right? So they will look for those phones which does not get heated easily and gives good and smooth performance. For that reason they will go for higher refresh rate. Refresh rate will help, so when you are touching a screen, so it should be very smooth without any lag. If you are opening a app, right, there should not be any lag, quickly it should open. So if you have a better refresh rate, so that lagging will reduce in your, right, screen lagging will reduce. That is refresh. So there are n number of features in mobile phone. So more the number of features in mobile phone, definitely what will happen? The number of transistor count will increase. Suppose instead of 128 GB, now you want 256 GB of mobile phone. What will happen? How to get that memory? What is the storage element? Flip flops, right? So flip-flop count, whether it will remain same in 256 GB as 128 GB? Obviously, no, right? So the number of flip-flops which are required in 128 GB will increase in 256 GB, right? So the number of transistors, the size is reducing. So you can have more number of transistors. That is nothing but we are evolving in terms of size of transistor and the IC integration, we can say, right? So I can like give you one example here. So there is a mux, right? 2 is to 1 mux. How many inputs and how many outputs are there? Anyone? In 2 is to 1 mux?
Two inputs, one outputs.
2 inputs, 1 output. Is it correct? Is it 2 inputs, 1 output or 3 inputs, 1 output? Hmm? There are 3 inputs or 2 inputs? There are 3 inputs, right? One is select line. So there are 3 inputs and 1 output. Now, how you can design a mux using combo cell? How many combo cells are required? Anyone? To design a 2 cross 1 mux. How many combinational cells? 4. What are those? What are those 4, Sridhar? You understand, right? How to design 2 cross 1. You might have learned this in your graduation in digital subject. That is why we will provide revision also. I understand there is a 1 year, 2 year, means past 2 years, before 2 years you have learned all this. Sir, how much time is still remaining? We'll conclude in 1 hour, 40 minutes. Okay. No, I mean combinational cells. How many combination, not combination of digital this thing. I'm asking about combinational logic. How many logic required? So 2 and 1 or and 1 inverter, right? So there are 4 logics. Now for each logic, how many transistors are required? How many transistors required for AND? How many transistors are required for AND? How many for OR? Yes, anyone who can answer this? Inverter also. So AND or inverter. How many transistors? Is it 4? Is it correct? Or 6? How many transistors for inverter? How many transistors for inverter? For inverter, 2 transistors. For OR, 6 transistors. For AND also 6 transistors. 4 is not correct. Okay. Now I'll just draw the inverter. So when we say transistor, it is nothing but MOSFET. Okay. PMOS, NMOS. So we are designing using what? CMOS. Right. So this is nothing but a CMOS inverter. So we have PMOS, and NMOS. So now can you tell me total number of transistor for 2 cross 1 mux required? What is the total number of transistors? 6 plus 6 plus 2. So there are two ends, right? So 12, 18 and 2. 6, 6, 6, right? So 20 transistors we can observe here. 20 transistors are required to design 2 cross 1 mux. Understood? 20 transistors. Now for 4 cross 1 mux, how many transistors are required? Can anyone answer? If you have understood this, you can quickly answer how many transistors are required for 4 cross 1 mux. 40 transistors, right? So how many 40 transistors or more than 40? So if you can use 1, 2, right? If you use 2 and one more, 2 cross 1 mux, 3 2 cross 1 mux. What is this? It is nothing but 4 cross 1 mux, right? S1, S0, I0, I1, I2, I3. These are 2 cross 1 mux, 2 cross 1 mux, 2 cross 1 mux, and this is nothing but 4 cross 1 mux. So 60 transistors are required if you design a 4 cross 1 mux using 2 cross 1 mux. Right? Now what is the jump? How much is the increment from 20 transistor to 60 transistor? 40 more 40 transistors are required plus 40, right? So suppose you are having this much of area only, right? You are having suppose some area X, right? Now you are having some technology node of 28 nanometer. Now you are able to design 2 cross 1 mux in this area X, right? In this particular area, you are able to design 2 cross 1 mux for 28 nanometer technology. So how many transistors are required? So we are seeing that it is filled with 20 transistors, already filled. Complete area is occupied by 20 transistors. Now there is no space left. Whether you are able to accommodate 40 more transistors, there is no space left, right? So you cannot accommodate 40 more transistors. You want more area, more bigger area, right? Compared to this one for 28 nanometer. Now let's say instead of 28 nanometer, now design is in 10 nanometer scale. Now what will happen? Using 10 nanometer, now definitely in half of the part of your design, you will be able to fabricate 20 transistor. The rest of the part will be remaining empty, which can be utilized for this additional 40 transistors to design. Understood? So if your technology node is shrinking, you can have more and more complex designs. So for this, we will follow a specific design cycle, right? Or a SIG design flow. The first step is to decide what specification, right? So what does specification means? So you need to decide what your design application is, what is the requirement of your design application, right? Is it a mobile processor, is it a washing machine, right? Based upon that you are deciding specification. Suppose the processor is for mobile, right? Definitely it will require certain amount of power, right? It should have some speed, and the area is also very important constraint. Suppose the design is for computer and laptops, right? What should be the design requirement? Definitely power is not the big thing, right? Because it is always plugged in if it is for desktop. right? Area is also not a constraint. You can have more area, you can take more area. Speed is very important there, right? But in mobile it should be low power. Why? Because it is a portable device. You will be taking from one location to other, so it should be low power. The area is also important. You should not have a very heavy phone, thick phone, right? It should be sleek, slim, right? So area we should use less, right, for chip. And speed is also important. You need very fast performance in mobile phone. So all power area is what our specification of the design. Suppose the design is for washing machine, right? What is the specification? That motor should be rotating properly, right? What should be the speed of that motor that can be controlled by the chip, right? Automated by the chip. How much water should be uh, given based on your cloth weight. If you want to do automation, that can be done, right? So in your processor or the SoC level architectural design in computer or TVs, right, you'll find that there is a set of memory design, there is a set of ALU design, there is a GPU also, display, speaker, mic, Bluetooth, Wi-Fi, USB, right, light sensor. So if you see the color coding, right, all these are digital designs. And if you see the blue color region, sky blue color region, are analog or RF based design. Okay. And the yellow color light sensor IPs, right? These are all what? Mixed signals, means both analog as well as digital component are fabricated or designed in this subsystem, right? So this is how specification is decided. See, for display, different specification will be done. So display does not needs to be, the speaker does not needs to be very fast, right? But it requires power. Memory requires both power and speed, right? ALU, the arithmetic logic unit, also requires speed, but power requirement is that much not required, right? So different subsystem and different sub specification is also there. So architecture, once specification is decided, then architecture is defined. Architecture means what are all components which will be coming inside your complete system on chip SoC design, like display or Bluetooth, ALU, CPU, GPU, right? What are all components? What are all blocks? So it is basically a block diagram, right, which will be there in architectural design. Okay. So the first step in the ASIC flow in the design level after architecture level, once block is decided, suppose ALU, CPU and memory, these blocks are there in your SoC design. Now each block will be designed separately. How it will be designed? Suppose ALU will be picked up, right? And what are the logics which is present in that? So for that, we are going to write one code. That those codes are called as RTL code, register transfer logic code. Okay, and now these codes are not written in C language or C++ or Java, right? These codes are written in hardware description language, HDL. These are called as HDL language. So what are, you might have also, some of you have studied in graduation and MTech. There are Verilog and VHDL, system Verilog. So these all are what? Hardware description language. So nowadays in industry, Verilog is majorly used, right, to design your electronic design. Okay. Now there are different model styles, right? Behavioral, structural, and data flow. So mostly in industry, behavioral model style is preferred to write the design. Okay. Why? Because it's have its own advantage. If you write a behavioral model code, you do not need to define the logic, right? You do not need to define whether it is and or. You do not have to think about it. Suppose I want to write a behavioral Verilog code for mux, right? How I can write a behavioral code for a mux, right? So this is why this is select line. So behavior means define the behavior, define the Behavior. What is the behavior of 2 cross 1 mux? So it is conditional, right? If s equals 0, right, then y equals, what is that? I0, right? Else y equals I1. That's all. This is nothing but 2 cross 1 mux. Do you see whether I have defined any logic? Have I defined any logic like AND or inverter? No. So no logic needs to be defined when you're writing Verilog code in behavioral model. If you're writing in data flow or structural, then logic needs to be defined. But for the Verilog behavioral code, you do not need to define any logic, right? So that happens in RTL designing. Okay. So after this, we have RTL verification, right? We need to verify the whatever RTL design is been designed, whether it is correct or not. So it is designed based upon test benches and test cases, right? So how you are going to test any design, right, or verify any design? So you have a design, RTL design is there, right? Or it is also called as DUT, design under test. So it will have certain number of inputs and a certain number of outputs. Based on inputs and outputs, you can decide whether design is correct or wrong. Suppose, let's say, let's say we'll talk about a small, very small design. So it has one input, one output. Let's say this is A and this is Y. So how many possible inputs can be there? How many possible inputs it can have? Anyone? So some logic, some design is there. It has one input, one output. What are the possible inputs it can have? Simple question. What are the possible inputs it can have? Two inputs, right? So it can,
Zero.
correct. It can have 0 or 1, two inputs. So if there are three inputs, how many possible inputs it can have? 2 to the power n, right?
8.
Power
Yes.
3 will have 8 possible inputs. Okay, so 0 and 1 means what? Suppose if you are giving input as 0, right, then what will be your output? What will be your output? If we do not know, James, right? We do not know whether it is 0 or what, because we don't know what is the design, right? If 0, if you are giving input as 1, then what is your y, right? So based on what you are getting at output, right? Suppose now we need to verify this design for inverter. Let's say we are saying that I have a RTL design for inverter. Now I'm giving all possible inputs and I'm seeing what is my output. I'm getting 0, I'm getting 1 here. Now whether, so this is my test cases. This is my test stimulus. These are called as stimulus. So I'm giving test stimulus. Whether I'm getting the desired output as inverter? No. So this design is a functional failure. Functional failure. It does not pass, right? So it is does not pass as an inverter. So your RTL design is not correct. You need to correct it. Right, and this is how verification is giving the feedback. The design has some functional mistakes, that is why you are not getting the desired output. Now if you are getting, let's say, instead of 0 you are getting 1, instead of 1 you are getting 0. Now what happens? Now this is functionally correct, so it is not a failure. Now it is passing. It is passing, right? So now this is just the output. So it is seen usually in the form of waveforms, right? So you will have some type of waveform. If you're getting waveform, white output waveform like this, if you're giving input waveform will be like this. So there will be timestamps at what time you're getting falling edge or rising edge. So this can be seen in different types of tools. There are different tools like Xilinx, Vivado, Model Sim, right? All these are tools which are helpful in seeing these test bench waveforms. What inputs you have given, based on that, what outputs you're getting. In this way, verification is done, design verification. Clear? So after this, once your design is verified, okay, you are getting the desired output now. Now what to do? Now we know that your design is written in what? Behavioral code, right? Your design is written in behavioral code. It does not have any logic. It needs to be converted into logical design, right? Or it is called as gate level netlist design. Means what? The gate must be defined. Suppose you have designed a inverter, right? Or let's say mux only, mux 2 cross 1 mux, right? Now you have just written if else statement, whether there is any logic. So there are no logic. So this needs to be converted into gate level file or gate level design. What is the process called as? Synthesis, which converts your behavioral design, RTL design, to gate level netlist, GLS, gate level netlist, or it is also called as GLN, gate level netlist, right? Now what happens? This logic will be converted into, and how many ands you are using? Two ands, and A1, A2, or 1, and inverter 1, right? So you will have proper how many gates are used and how these are connected. So inputs and outputs and wire, which wire is connected to which input and output, right? We will see in course also, we'll see synthesis more in detail, right? We'll understand more how it works, how it is converted. Now these are mapped with the technology node. To be noted that these are mapped with technology node, purely technology dependent, whereas these are not technology dependent. Okay, so this is synthesis, right? So this happens. So you have written some code. It will be converted into what? A gate level netlist, where each gate of it will be converting your behavioral design into each gate level information. You can see this is one of the example. So after you get a gate level list, right? The next is the DFT, right? So DFT is usually part of design flow, which is used to improve the testability or testing feature of your design. How you can improve the design? So you have to improve the testing feature also. More it has the better testability feature, more your design will become robust. Let's say there are two cars, one is Jaguar car and another one is your Nano car. Obviously we know that Jaguar car has passed more number of tests compared to Nano car. So Nano car will fail lot of physical and safety test, right, during manufacturing. That is why cost will also define based on its testing feature. So how we can improve testing features, right? We can have automated testing pattern generator. We can have BIST kind of logics, right? What is BIST? It is called as built-in self-test, right? Or memory BIST, MBIST, right? If these uh, logics or algorithms are included in your design, what will happen? This will help in improving the testability of design. Yes, Archita. Synthesis is converting Verilog code to gate level netlist. But the only difference is those gates are technology dependent gates. So the first step, so it's till synthesis, we have completed synthesis, we got the gate level netlist. So from here onwards, our physical design starts. Okay. So in this physical design, so usually the physical design is nothing but the physical implementation of your logical design, right? The so the first is the specification, decide the specification, then decide the architecture, then decide the behavior of your design, RTL design, if else or something like that. We don't know about gate and all. They're just behavior, right? Then verify it. Design verification team is there to verify it. Then comes what? Convert that, if it is verified, convert into what? Gate level information. So that will be happening in synthesis. After all this is done, right, we'll have gate level netlist, right? Now this will be used for physical implementation. So from real VLSI starts from physical implementation only, right? Till here everything is what? In theory or logical, right? Nothing on physical aspect we are thinking, right? Everything is logical and theoretical. It will work in physical or not, we are not sure, we are not caring here. So these, till before synthesis, it is called as front end. It is called as front front end. Whatever you are doing, right, in architecture, RTL design verification, all this comes under front end. All the physical implementation activities from here onwards, it is called as back end. Okay. So in complete design cycle, your 60 to 70% time of designing is consumed in physical implementation. In 30% of time will be consumed in design verification or RTL development. So it will complete in less number of time compared to this time. So more time is consumed in physical implementation of design. So first stage in physical design is floor plan, right? So physical implementation means whatever logic gates, macros, memories, right, you have in your design. Now those cells needs to be physically placed in your design, right? So you see these blocks are nothing but macros and these are ports, you can see. Now there are two regions, one is called as die, one is called as core. So the cells will be placed inside core in these respective rows only, right? These rows are nothing but the markers, and these are the ports which will be placed in IO regions, input output regions. Okay, so this is the height and this is the width of a floor plan. The first stage is to decide the area, that is by defining the die and the core area, right? Then place all your ports, right? Then you need to create, if it is a multi voltage design, you have to create separate voltage, the components which will be operated on the particular voltage, it will be placed in those area. Then macro placement is placed, right, according to the guidelines. Then there will be physical cells, those are tap cells and end cap cells, right? Then you need to create a blockages. Then you need to give power supply, right? Because these cells are not connected to any power, right? You have to provide power supply also. So giving power is also art here actually. It's not like doing electrification for your home. It's very complex and very, you have to be very strategic here to define and provide power to all the logical components. It's not like directly giving single line or so I can just explain one issue here, right? So what happens if this is my design, I have placed some cell here and here, right? So what I will do, I will use power lines from port P, power, ground, VDD and VSS. I'll give VDD and VSS here. And from here, I will take VDD and VSS to this cell also. This is cell 1, cell 2. Right? Is it a good way of designing? Right? What could be the problems? What could be the problems? Yes. No, there is no overlapping here. So I'm talking about with respect to power. If you see, this is having more length, not area wastage also. You can see length is more, right? So if length is more, what could be the possible problems? Correct. It is voltage drop. So when we can see IR drop, right? So let's say you have a voltage. You have a voltage of VDD, right? So you are giving what? VDD here, supply. VSS here. Whether you are getting same supply to this cell, is it? No. Somehow there will be power loss due to this long net, right? Due to parasitics. Of course, power loss can be there. And power loss is dependent on the IR, and it depends on what? Length of that net. More the longer net, right? More will be resistance. If IR drop is increasing, what will happen? Your new supply voltage to the cell will be V naught minus IR. If IR drop, voltage drop increasing, your effective supply will reduce. So your V naught dash will become VDD minus IR. So this will be your effective supply which is reaching to this cell. Understood? Here also length is increasing, right? So this will also lead to some voltage drop, right? Now how this can be improved? The improvement can be that this cell can be placed near to this supply. This cell can also be placed near to this supply. But whether it is a good solution that you place all these cells near to supply only, what will happen if you place all this cell near to supply? That is not a good idea, right? All this space remains empty, right? Heat and major thing is what? You can see congestion. You will see congestion here, and these all space are area waste. So what to do then? So better solution is that, what is a better solution? Capacitance, no. What is a better solution? Better solution is that you give multiple number of power lines. See, it is similar to like you have used bread. Yeah, I don't know how many of you use breadboard. Have you seen breadboard? It has lot of pins, sockets like this. Have you seen breadboard? Right, like this, somewhat like this. And what we do usually, we'll give, we'll define one complete line as power and one complete line as ground, VSS and VDD, and we'll mount components on top of it. Suppose we need VSS, we'll take a VSS line. Suppose we need a VDD, we'll take VDD line. Like this will mount, remember? But this is a very small board, right? Let's say it's a very, very huge board. Then your line, VDD line and VSS line is here. And you're placing component here. So it has to draw the power from here and ground here. It is a long distance. Then what you can do? You draw another common line of VDD near to this cell and another VSS line near to this cell. What will happen? You can easily get supply. Same way, you can draw multiple VDDs, right? And multiple VSS. And now when cells are placed, cells will be placed where? Anywhere it wants. Let's say it is placed here, it is placed here, it is placed here. Now what will happen? If this cell requires power, right? It will take it from the nearest supply. It will take it from the nearest supply. So that will reduce, right, your IR drop for these nets, PG nets. So this is just one challenge I have explained you here. Now, EMIR analysis will not be covered. So we are focused on physical designing. But while doing physical design, you also need to take care of these things also. Because if your floor plan is good, then definitely you will see less EMIR issues. Right? You are a designer. You are not going to analyze things. Analysis part is done by PDN person. Okay, next after floor plan we have placement. Once you have placed all the major block in your design, then wherever space are left, now those needs to be filled with standard cells, right, or standard cell logics inside the core. But we also need to make sure that these cells must be sitting exactly on site row. If you see, this is called as global placement or course placement, right? What is the difference here? You can see that it is not a legal placement of this cell. It is similar to parking lot, right? Have you seen parking lot? In parking lot, right, they will, not like this, they will make markers, right? Something like this. They will create markers and they will tell you to park your car exactly in that marking. Do not cross this border. So you are parking your car here. So this is like a marker. So suppose you're parking your car like this. Whether it is a legal parking of car? No, right? It is a illegal parking of car. Similar way, in placement also you need to make sure that cells are placed exactly on the rows. You can see the second figure where it is showing legal placement of the cells. It should be placed in exactly on the site rows. So after this you need to check congestion as well as how much timing is getting improved or getting bad, right? So once you have placed all your logics, all your cells, so then what is the next step? Next step is provide all cells, right? We need to provide clock to all cells. See, we have placed cells, we have provided power also. Now the second thing is you should connect all these cells with clock nets, right? Now just providing clock nets is not our goal, right? If you provide clock nets directly to these cells, what will happen? What will happen? So if you have multiple number of cells in a design, these are multiple number of cells and this is your port. If you provide and connect clocks from, this is clock, from clock port you are giving uh, this one connecting like this. Is it a good way of connection from clock port to these sequential cells? I'm giving clock to all these sequential cells. Is it a good way of designing? Or let me draw another one. So now you have these cells like this. Or else what I can do, there is another way of giving clock. I will right. Which one is better, 1 or 2? What do you feel? This is also clock. These are what? Cells. Cell 1, cell 2. Which one is better? 1 or 2? So these are nothing but clock nets. Clock nets. Why you feel like, yes, everyone is saying 1 only. Why you feel 1 is better than 2? Or 2 is better than 1 if you see, if you think 2? If you see the first case, right, it is quite, it looks like organized if you see, but here what is possibly, you can see, right, lot of tracks, right, it will be utilized here because every net is coming from port, right, there is no common path. What will happen, this will lead to congestion, right? If you follow this, better way to have a common net, and from there we can create branches. So there are multiple CTS algorithm like H tree, right, X tree, pi tree. So there are multiple algorithms to follow. So this is the example of fishbone algorithm. Fishbone algorithm. Okay. So that is why. So important thing is that the clock must be balanced properly. Balancing means we need to balance the skew as well as latency to help, which will help us in timing and power optimization. So once the CTS is completed, the final stage is the routing stage. So what happens in routing stage? So all these logic, memories, and your all your sequential cells and logics, you should be providing signals, right? Data signals. See, you have given power in floor plan, you have given CTS, and the last thing is what? Signals. See, clock pins are connected. Now you should connect data pins also to all these physical logical cells, right? How you are going to connect? So in that will be connected in routing. Using metal layers, you are going to connect all these logics. So that is the last part, signal routing. So we should also make sure that when we are connecting all this, that congestion and the timing and our specification should not get affected. Our performance, power, and area should not get affected. So after routing, if everything is fine, if sign off is getting cleared, like if you're meeting the expected timing, you're meeting the expected IR drop, right? And if you're meeting the physical verification part also, like there should not be any DRC, there should not be any LVS, there should not be any functional failure also. If everything is cleared and green flagged, the final output we can generate is GDS2 file, right? And this file can be sent to fabrication lab for fabrication, right? Fabricating of chip. So these are the list of tools for each stage. So we have discussed synthesis, which is design compiler is used for synthesis, for placement and routing ICC2, for SPEF extraction star RC, for STA prime time, for physical verification IC validator, for sign off, power sign off, we have prime power. Prime power can be used. Okay, so this is the physical design flow, right? have sanity checks, floor plan, power plan, CTS, pre-placement, placement, CTS, routing, and sign off. Okay, so this is the overall briefing which I have given to you on VLSI and overall design flow as well as physical design flow briefing. I have given what is happening in industry, what is going on. Okay, fee structure, you can check with the management, right? I am here to tell you about course and course brief. Also, I will, I have told, right? So I will also tell there are different types. Okay, previous PPT, this slide or this slide, this slide regarding tool. Okay, so you can ask me any question if you like to ask. If you have any doubts, any question, I'll be answering all of your questions. So I'm open for questioning, Soham. If you have any specific question, you can ask me. For those tools to work, what are the basic specification? It says basic specification. Let me tell you, you should have at least dual core processor and with the 256 GB of memory. 128 is also fine. RAM, minimum RAM required size is 2 GB. So we'll be using those tool which is related to physical design, Abhijit. So we'll be mostly working on ICC2 where floor planning and placement and routing will happen. And we'll also use prime time for STA sign off, timing sign off. And spec extraction, we will use a star RC to generate RC file. And we'll also use design compiler for synthesis. Layout we are not doing, so layout tool is for custom layout domain. Those who have taken that course, they'll be using custom validator or ICV, physical verification. Those who have taken layout, they'll be learning ICV. There are the tests based on concept or tool, both, right? So there will be one theoretical and MCQ based test and written test also. And there will also be lab test, tool based test will also be there. So when will allow to placement? Once your course is completed, you will be added to one placement group where they will publish opportunities and they will make you prepare, like they will give you support on soft skill, resume screening, all those support they will provide in that placement group once you have completed your course with good performance. Sir, where can I get login details for online classes recording? You can check Santosh with management on that. So they will provide you tool access, login access based upon what type of course mode you have applied in. Right now, in which field there is more scope, front end and back end. So it's not like front end and back end has more scope or less scope. Like I said, to develop a chip design, right? Both front end and back end is required. Both front end and back end is part of the design cycle. It's not like physical design required and front end people not required. Both are always required. It depends company to company, which has certain type of openings. Usually in industry, the design verification and the physical design uh, engineers are more compared to other domain. Sir, we have to bring our laptops for lab. Yes, of course, you have to bring your laptops for all the lab session. So just I will mention the minimum requirement. You should have 2 core processor, 2 GB RAM and 128 GB memory. And Win if you are a Windows person, Windows 7 or 8 will be fine. This is the minimum requirement for laptop. Do we have classes after lunch? So there are 2 slots I have already told. One will be morning slot and one will be post lunch slot. So based on your batch preference, right? Post lunch, you will be getting that slot. 2 slots. Batch preference and trainer availability. Either it can be morning slot, which is before lunch, or it can be after lunch. Lunch period will be mostly 1 to 2 p.m. So the second batch usually starts at 2 p.m. Do we have classes, sir, for the physical design pressure? So this question I will answer like I said. So many people have this doubt like you are a fresher or the recent pass out, you have passed out at in 2025 or 2026. What are our chances? What are our opportunities? Yes, VLSI usually shies away from hiring the freshers. That is true, but it's not like you will not get selected anywhere in the VLSI stream. There are many service-based companies which hires freshers. Like I'll give you some name: Wipro, TCS, Infosys, HCL. All these hire. Apart from this, there are many startup service-based companies and some good VLSI service-based companies are also there, which are mid-range company which started 5 years back. They also hire freshers, right? It's not like there are no openings for fresher, but some of these companies will usually hire the freshers. Also, the product-based companies like Qualcomm, Samsung, right, Intel, they also hire freshers, but usually they do more campus hiring. And by campus hiring, I mean from the tier 1 colleges, IIT, NITs, BITS, all these colleges will have these companies. Sir, after completion of project 28 nanometer and 14 nanometer, how much work experience we will gain or we can add in our resume? To very much, very much. So after this course, you will be in a very good state. So there are many freshers who do not have this hands-on. So most important part is the concept, the advanced concept we share and we teach you here. And second is the application of that concept. So we will make sure that you are able to apply this concept in real life, aligned with the real life industry level work, right? For that, we have EDA tools, which is industry standard EDA tool that is from Synopsys ICC tool, which will help you in designing and get you a hands-on experience, right? See, ultimately what happens? So when a company will hire you only if you know, uh, if you're ready to work, right? And these company work on these EDA tools only. If you have this skill, right? So we'll help you not only theoretical concept, will help you in skill development also. So skill development not only with respect to the technical skill, will also help you in your soft skill like communication, interview, right? How to discuss. All this will be covered in soft skill. So there also we will help you in your improvement. I585. This is very much high, right? I have given you very least specification. Minimum is i3 dual core. This is fine. This is more than enough. Sai. PPT you can check with management Santosh. They will share it to you. Yes, any other question? Any other specific? Archita sir, how who can go into who can go into physical design side and design verification, and which has the more scope? See, like I said, it is completely based on interest, right? What is your interest? What you feel? I clearly tell you difference. So the design verification part is more of verifying the design. They are not involved in designing something, right? They are just involved in the design, verifying techniques of the design, right? So when we are verifying things, you should be very good in coding actually. So there will be coding. Which coding? So coding like .v, system verilog, and some advanced verification techniques like UVM, and there will be some protocols. So all these are related with coding. Concept wise, you should be good in digital system design. Okay, so this is required for DV. Now whether you it makes you interesting, if you feel interesting, then you can of course choose DV. Then we have PD also. PD is basically not verifying things. PD is a designing or physical implementation, right? It is a designing part. So where you should be very strong in, right? Strong or good grip in concepts and basics, because these needs to be applied while designing a chip, right? For this, the basic you require is CMOS, digital, which we will be providing you support in the basics also, right? Coding is very less here, almost none, right? So I'll say like 2%. That's all. So most important is the understanding of subject is very important in physical design. So if you are interested, if you interest, you can go. Opportunity wise, I think both have same level of opportunities, right? More number of opportunities, more number of openings here also, right? Compared to other domains like analog, custom layout. So these have very less openings in comparison with DV and PD. So let us go to next. Sir, we don't have to join today afternoon. Today afternoon, I'm not informed that whether there will be session or not. Can check with the management. Sir, is in physical design we use only tools and technologies or any code? Like I said, so code usage will be 2%, 2 to 5%. More important is the understanding on concept. So there are interrelated concepts are there. Understanding is very crucial in physical design. The understanding the concepts actually. I have 5 years of career gap, worked in non-IT marketing. Okay. Non-technical, it becomes non-technical now. So will I have a placement opportunity after completing of course? If yes, what will be the scope in this VLSI industry? Will I go as fresher and experience? Say you will be going as a fresher, right? Your past experience in marketing won't help you here, because first of all, it is a non-technical domain, like you're saying, it is a marketing. Okay. So, and second misconception I want to clear here, that VLSI is not a IT. Okay. VLSI is also a non-IT. It is not a part of information technology. We are not doing information technology here. This is not a software designing, right? VLSI designing is a purely 100% hardware designing. It is not a soft. Do not compare with IT software designing, right? It is not a software designing. Whether it is front end or a back end, both are part of hardware designing. Sir, after completion of PD course, we will get completion certificate. Yes, you will get a completion certificate. Is there any chances of getting any kind of experience certificate through our institute possible? I'm not sure about that. You can check with management and all. But after the completion of course, we will be providing you the completion certificate. I am already working in CAD in product based. Will PD be better? Okay, which product based or which CAD you are working? Is it a EDA? Is it an electronic design automation tool? That you should clear, Abhijit. Yes, Abhijit, backend EDA synopsis tool. Okay. So have you means in your work, have you done something on PD, any IP development, any IP testing, IP designing using this tool? So thing is, let's say you have done something there, right? And you have a good experience in EDA synopsis tool. Now there are many EDA tools, many synopsis tool. Which tool you have experience? That also you should mention. Which tool? Which backend tool? Sir, any idea regarding placement package? Placement package, see there are different types of companies. There are majorly two companies. One is service based and product based companies. So majority of opportunities you will find in service based companies and very less openings will be there in product companies. But product companies pay more compared to service based company. Service based company usually provide their services to these product companies. Service based, you will have more number of openings, more number of opportunities in service based companies. So the package which starts in service based companies is around 3 to 5 lakhs, the starting package as a trainee. When you are training, right, for 6 months they will provide 3 months to 6 months they will provide training. For that they will give you between 3 to 5 lakhs. After training, when they will send you to some client, it means to product, then they might increase that package based on your performance. No PD related, only with respect to layout. Okay, but still you have some idea on EDA and PD. So I'm not sure how much experience you got there, but definitely it will help you because synopsis is part of VLSI design flow. So you will have a edge, but you will not have a big impact, but definitely you will have some edge to get a job in PD after this course. Sir, with the 5 years gap, what is the opportunity get placed? As I've heard, most companies ask me. So you have a good opportunity side. So if you have a year gap, 5 year gap, so usually you have a good opportunity. Now recruitment as a trained fresher. Trained fresher, you will be trained and then you will be joining some service company. There they will train you again. They will train you according to the client. Suppose they are sending you to client to something like Broadcom or Intel. They will train you according to the client requirement. Suppose the requirement is there in STA. So they will train you in STA also, companies. If based on requirement. If requirement is in PDN, they'll train you in PDN concepts. Yes, any other question? Sir, in PD previous batch, how many students got placed from our institute? The exact number, I didn't got the exact number for the last batch, because last week only I have completed last batch. So I need to check with the management. Yes. Any other question related to course? So let me tell you that the sessions will be regularly present. You should attend all the session. Second thing, there will be recorded sessions also, which will be provided to you. If you miss some sessions due to some reason, you can watch recorded session also, right? And you can cover up. For that reason only recorded sessions are given. So there are two modes, online and offline modes. So you can choose any one of these based upon your preferences. But if you have chosen offline, make sure you are attending on offline sessions. But if you are chosen, don't do like this, that if you are chosen offline and then you are some days going online and some days offline, some days not attending also, that won't help you, because these people will, the management will also track your attendance also. So make sure you attend all the sessions. Sir, in PD previous batch, how many students got placed from our institute? This I have already told you. I need to check for the last batch, which was completed last week. What will be the salary of this? I have already answered, right? Sai? Over years of knowledge from our institute. See, once you have passed from our institute, right? You have passed from institute, you'll go into some XYZ company. After that, institute does not matter. After that, your performance matter, how you perform in this XYZ company. If you are performing good, definitely you will grow good, you'll go to next good opportunities. So after that, this training is just a, you will feel that this is the starting phase or the starting learning phase. There are many things you will understand once you are learning more and more over the course of period. Sirisha, Ram, you can check with the manager. They will let you know about the PPT. Yes, thank you, Abhijit. Is any other question? So there are two questions which I haven't answered. Let me tell you. One is the batch, next batch schedule, both Bangalore and Hyderabad. So you have to check with the manager. Second is fees. This also you can check with manager. The schedule and the fees. When next batch is starting in Bangalore and Hyderabad, and fees. Check with manager. Sir, can I call you after meeting? Can you please share your order? So I'll give you manager's number. Yeah, about the company tie-ups. This also you can check with manager, because he is handling the training and placement cell, companies tie-ups. So I'll give his number. You can note it down. Manager's number. 889 888 2238. His name is Vaibhav. Yes, any other question? Yes, after the PD basic session, the basic sessions, we will have one test. So you have to clear that test. Yes, that is correct. If you pass the PD basic test, then only you will be moved to advanced sessions. No, you will not continue. If you fail, you will not continue the basic batch. You will be provided with the revision sessions. Usually, what I have seen in previous batches, people will pass in basics. Sir, is a company that hires fresher for PD? Or yes, I have already answered that, Archita, that there are many companies which hire fresher. So basically, you have a good opportunity in service-based companies. Product-based companies also hire freshers, but usually through campus hiring most of the time. That is also from Tier 1 college. Yes, once you are in final stage in CTS or in routing stage, when there is only 1 or 2 months left, right? If there is a good opportunity in last of your 3 months or last 2 months, so if there are good opportunities, then definitely your resumes will be asked. If they suppose in the last 6 months there was Wipro hiring was going on in our institute, so they requested us more than like 100 students. Actual requirement was more than 100, so it was more than like 200 students, but we don't have that much of people. So if such kind of opportunity is there, definitely in between course only you will be approached. No more question? Okay, we'll stop this session here. I hope as a trained PD, what are other different types of roles we have, sir? See, Archita, let me tell you that, see, as a trained PD, you can go into synthesis, you can go into PD, you can go into power, you can go into STA, you can go into DFT, right? DFT, no, you cannot go. There is a separate course. Then you can go into PV, right? You can go choose any one of these domain. These are all part of PD only. Miss not directly, but somehow you can go into sign off basically. Okay. Okay, thank you everyone. I hope you liked my session and I hope that you are wishing to join the course. Tool access will be for how long after completing of course. So the usually there is 1 to 2 weeks of extension is given, or that is only based on request if you require. If student access gets expired, we have. There are no open source tool in physical design side. Even though it is there, you cannot work in lower technology nodes. You will be requiring a licensed tool only to design a complex design. Okay, thank you everyone. If you have any specific question, you can regarding fees, company tie-ups, or batch schedule when next batch is starting. You can check with my institute's manager. Okay, thank you. Open source tool is not there. See, tool is not developed by us. Tool is developed by EDA tool companies, Synopsys and Cadence. They will not give it for free to everyone. So we have that license. Institute has purchased the license from EDA tools, which will be provided to our students. See how we can provide industrial level projects without having a practice, Sharmila. So whatever projects you will be doing here, you can keep that in your resume. That is more than sufficient. It is a 28 nanometer project we'll be taking here in the lab session, and it is a multi-voltage design which will be helpful as a fresher opportunity. Yes, sir. If I want to practice, then so if course completes and your tool access is gone, so we'll provide 1 week of extension based on request. And if you want, let's say you want 1 or 2 more months tool access, you want 2 more months, then there is extra chargeable amount which you have to pay to get that extra tool access. That you can check with the manager, like what will be the amount and how it is done. It will be much better for me to get your. We don't have any air conditioned classroom. Okay, in Hyderabad, I'm not sure. You can check with manager. In Bangalore, we don't have that. Recently, the Hyderabad is started actually, so I'm not aware of it. When is the batch going to start offline? Like I said, check with manager side on schedule, fees, and company tires. Okay, everyone. Thank you. Thank you for your cooperation. I hope you like my session and you're wishing to join the course. Thank you.